Now we're going to go over another of the most common mistakes that students have on their data tables, and that is having to do with significant figures. Most students screw up the significant figures for a lot of their numbers, and so I'm just going to take some time to correct the significant figures on this particular data table so you can see how I do it and you can see me use the rules to fix it. In addition to that, the purpose of me doing this is to show you how to prevent Excel from auto-rounding things, because it will auto-round, and there's a quick, slick way to correct auto-rounding and to round your all your numbers to the correct decimal place according to your sig fig rules. So let's take a look at each value and just make sure they're all right. So let's see here. The height of the books is a measured number, and all your numbers, whether measured or calculated, must have the same precision for the number as they do for the uncertainty. By precision, I mean they should be listed to the same decimal place. For example, this one, 3.3, is listed to the tenths place, and its uncertainty is also listed to the tenths place, so 1 decimal place. That's good. They match. That's fine. This one's fine. It's this one that looks like is a problem. The rest look like are fine. So this value here, the height of the books, 10, is a measured number, and it's not matching its uncertainty. The rule for measured numbers is that you round the measured number to fit the uncertainty. So this needs to be rounded back up to 10.0. And I bet you anything, the student actually probably measured and probably even wrote in 10.0. It's just watch what Excel does when you put in 10.0 and hit enter. It auto rounds back down to 10. Excel is assuming that you are putting in exact numbers. So it doesn't really matter if you write 10 or 10.0 or 10.0000. It's all the same number regardless. And that's fine for Excel because for the most part that's good enough for all we care about. However, there are situations in which it matters, and those situations mostly has to do with doing a lab, which is what we're doing. So we need to make sure the significant figures are correct. There's a fast way to fix it. Notice I highlighted all the number values in that column, and they're all going to have to be listed to the same place anyways, the tenths place. So what I'm going to do is I'm going to click on the Home tab, and I'm going to come to this area here where it says Numbers, and I'm going to, there are two buttons, one says Increase Decimal, one says Decrease Decimal, and I'm going to simply play around with these numbers, right? If I hit Increase, it increases the number of decimal places, Decrease decreases, and I'll click around until I get them all to be 1/10. So right now they're all listed at 1/10. That was quick and easy to do. So now they all match, perfect. Let's go look at the next one. Length of the incline is listed to the tenths place. The uncertainty is listed to the ones. It's a measured number. The rule for measured numbers is that the uncertainty is king, right? We talked about that in a previous video. That's my quick way of saying you match the number to fit the uncertainty because it's king. So we will round this guy up. Let's see, wrong way. And we'll round this guy up so it's at the ones place. All right, acceleration. Most of them are listed to the, what is that? The tenths, hundredths, thousandths, 10,000ths place, 4 decimal points. All except for that one. I bet you anything was 3900. And this is only listed to the thousandths. So the uncertainty is. So we will round these, again, wrong way, round these down. And we've got it to match now. And even that one matches. All right. Now these numbers down here are calculated numbers. So the rule for calculated numbers was we had to figure out the number of sig figs for the number itself by using the rules for sig figs and calculations. And then the number itself is king, and you just match the uncertainty to that number. So I'm going to look at this number, and I doubt it's right, and I say, how do I get I'm sure the number's right. I doubt the number of sig figs are correct. So then I ask myself, how do I figure out the number of sig figs? Well, I think about how it was calculated. It was division, and I follow the rule for division in my pink packet. Well, I used this value and divided it by this value to get the sine of the angle. I did height divided by length. The height has 2 sig figs, the length has 3. I go with the smallest number, sig figs 2. So I have to round this up, whoops, wrong way. Round this up so until it has 2 significant figures, and there it has 2. Remember, the leading zeros don't count. So 2, 0, that's 2 sig figs. Notice it may have 3 decimal places, but we don't care. It matters the sig figs when multiplying and dividing. All right, we'll do the same thing here. This one has 2, this one has 3 sig figs, this one should have 2. This calculated number. Boy, I keep on going the wrong way, don't I? All right, that's good. This one has 3, 3, so this one should have, the final calculated number should have 3. Oops, too far, 3, okay. 3, 3, actually they're both 3. So, oops. I'm just going to change them both at the same time, make my job a little bit faster. 3 and 3, sig figs. Okay, now, look at this. This has 3 decimal places, 3 decimal places, and this one is listed to 4. That's because I still needed 3 sig figs, right? And so it took 4 decimal places to get 3 sig figs. It doesn't match with each other. That's fine. There's nothing wrong with that. We followed the rules of sig figs, and that's what matters. Now we've got to match our uncertainty in the sign of the angle to fit. So we will round them all down, except for this one, right, ended up being, sorry, not far enough. Round them all down to 3 decimal places, except this one has 4. There we go. So we matched the number of decimal places of these over for this, right over here, to match the number. Okay, acceleration. The rule for acceleration and calculated value is it just should have the same as the trials. These all have 3 decimal places. So we will round these down so they're 3. Done. Okay, and these should match, so we will round these down, whoop, too far, till they're 3. Okay, so we have just fixed all the sig figs in our lab, and we're ready to start graphing.